In the spring of 2008, a Florida beekeeper named Dave Hackenberg opened his hives after winter. He expected the usual picture: some colonies weakened, a few lost to the cold, the rest active and ready for the season. What he found were empty hives. Not dead bees, that would have made sense. Emptiness. The queen was there, the honey untouched, the brood, larvae not yet raised to adulthood, still in place. The worker bees had simply left and never came back. No bodies, no traces, no explanation. Hackenberg lost 2,000 colonies out of 3,000. He called other beekeepers. The same story was unfolding across the country. Over the next 2 years, the United States lost roughly 30% of all honeybee colonies. In some states, more than half. The phenomenon was named colony-to-lapse disorder. Scientists still don't fully agree on what caused it, but here's what isn't in dispute. A bee is not just an insect that makes honey, it's infrastructure, as essential as roads, power grids, and water systems. Except it's alive, and it's vanishing. Today we're going to break down the bee properly. No romanticizing, no panic, just the facts, and they'll turn out to be stranger than any myth. Let's start with a scale most people never fully grasp. There are roughly 20,000 species of bees on Earth. Most people know one, the honeybee. The other 19,999 live quietly, alone or in small groups, pollinating plants, building nests in the ground, in hollow stems or cracks in rock faces. They're invisible to us and completely irreplaceable. The western honeybee, Apis mellifera, is the one humans have kept for millennia. Originally from Africa and Eurasia, it spread across the globe alongside human civilization. That's the bee we're talking about today. A worker bee is about half an inch long. It weighs around 120 milligrams. You could rest one on your thumbnail and barely feel it. And yet inside this tiny creature are compound eyes that see ultraviolet light. A flower that looks solid-colored to you looks to a bee like a runway with landing lights pointing straight to the nectar. Evolution struck a deal. The flower signals the bee carries the pollen. On the hind legs are pollen baskets, small hollows lined with stiff hairs. The bee combs pollen off her body, moistens it with nectar, and packs it in. A loaded bee flies back with bright yellow or orange pellets on her legs, those baskets packed to capacity. The antennae are multifunction sensors: scent, temperature, humidity, air vibration. A bee is constantly reading the world around her. And the brain, 1 milligram, smaller than the period at the end of this sentence, about 1 million neurons. For comparison, humans have 86 billion. What that single milligram can do, we'll get to in a moment, and it will surprise you. One hive isn't simply a lot of bees in one place. Biologists use the term superorganism. That's not a metaphor. A hive functions as a single living entity where each bee is an organ. Individual bees don't make decisions in their own interest, they make decisions in the interest of the hive. 40 to 80,000 individuals at the height of summer, one queen, a few hundred drones. Everyone else, worker bees, females with undeveloped ovaries who do literally everything. The queen lays up to 2,000 eggs a day, almost continuously all season. She lives up to 5 years. A worker bee in summer lives about 6 weeks. Drones, the males, don't work, don't guard, don't gather nectar. Their one job, to mate with a young queen. In autumn, once that job is done, the worker bees simply drive them out of the hive. The cold finishes them off. It's not cruelty, it's precise calculation. No point feeding extra mouths through winter. Worker bees follow a system of age-based roles. A bee just emerged from her cell spends her first days cleaning. Then she becomes a nurse, feeding larvae. Then a builder, secreting beeswax. Then a guard at the entrance. Only in the last 2 weeks of her life does she become a forager, the bee you see flying from flower to flower. Every bee knows what to do. No orders, no managers. Coordination happens through pheromones, chemical signals. The queen doesn't issue commands, she releases substances that regulate the behavior of thousands of bees simultaneously. If she dies, the pheromone balance shifts, and the hive immediately begins raising a new queen, automatically, no panic, no meeting required. This is a management system that engineers and computer scientists have studied for decades and still can't fully replicate. In 1946, Austrian biologist Carl von Frisch announced something his colleagues initially refused to believe. Bees communicate through dance. A bee that finds a good nectar source returns to the hive and performs a dance right on the comb. The shape, a figure 8 or a circle. The angle of the run relative to vertical encodes direction relative to the sun. The duration and intensity encode distance. The character of the movements conveys the quality of the food. Other bees watch, touch the dancer with their antennae, and fly directly to the indicated location, miles away. In 1973, von Frisch received the Nobel Prize in Physiology or Medicine for this discovery. Think about what that means. A creature with a 1 milligram brain transmits precise coordinates of a remote location using a language that other creatures understand without any training. Bees are among the very few animals on Earth that use a symbolic language to communicate about objects that aren't present. We long considered that ability uniquely human. There's one more detail that makes this even stranger. When several scout bees find different food sources and return to the hive at the same time, they essentially argue. They dance simultaneously, interrupting each other, recruiting supporters. The scout whose source is better dances more energetically and longer. Gradually, the majority begins supporting the better option. The hive flies there. That's a vote, a horizontal democracy with no leader in a creature that has no language in any sense we'd recognize. Honey isn't just a sweet substance. It's the result of a complex biochemical process that takes weeks and requires thousands of individuals working simultaneously. A forager bee sucks nectar from a flower with her proboscis and stores it in her honey stomach, a separate organ disconnected from digestion. The honey stomach holds about 40 milligrams of liquid. To fill it, a bee visits anywhere from 100 to 1,500 flowers. Transformation begins right there in the honey stomach. The enzyme invertase breaks down the sucrose in nectar into glucose and fructose. Back at the hive, the forager passes the nectar to a house bee through direct mouth-to-mouth transfer, who puts it into her own honey stomach, processes it with more enzymes, then passes it to the next bee. This chain repeats several times. Water content drops from around 80% down to 20%. Then the bees spread the nectar across the cells and begin ventilating, fanning their wings to move air through the hive. Evaporation continues. When moisture falls to about 18%, the honey is done. The bees seal the cell with a wax cap. 1 teaspoon of honey represents roughly 75,000 miles of total flight and about 2 million flower visits. Over her entire life, 6 weeks, a single worker bee produces roughly half a teaspoon. If you ate a spoonful of honey, you consumed the work of about 12 lifetimes. Honey doesn't spoil, ever. Honey found in Egyptian pharaohs' tombs, 3,000 years old, was still edible. The reason? Extremely low moisture content prevents bacteria from multiplying. An acidic environment with a pH around 3 is hostile to most microorganisms, and the enzyme glucose oxidase produces hydrogen peroxide. Honey is a natural antiseptic with an indefinite shelf life. During World War I, when medical supplies ran short, honey was used to dress wounds. Modern research confirms it. Certain varieties, particularly Manuka honey, are effective against bacteria that have become resistant to antibiotics. Everything we've covered, honey, wax, propolis, royal jelly, is not the most important thing bees do. The most important thing is pollination. 80% of all flowering plants on Earth depend on insect pollination. A third of all the food humanity eats exists because of bees. Let's be specific. Apples, pears, cherries, apricots, peaches, bees. Cucumbers, zucchini, pumpkins, bees. Almonds depend on bees for 90% of their pollination. Strawberries, raspberries, blueberries, bees. Coffee, bees. Chocolate, bees. Sunflowers, bees. Grain crops, wheat, rice, corn, are wind-pollinated and don't depend on bees, which is exactly what the math points to. Without bees, humanity could survive on bread and rice, without fruit, vegetables, nuts, chocolate, or coffee. But that's not the full picture. Without bees, it's not just crops that disappear, it's the wild flowering plants that form the foundation of entire ecosystems, then the insects and birds that feed on those plants, then the predators above them. The collapse cascades upward. One hive pollinates an area of roughly 2 to 4 square miles in a single season. The economic value of pollination provided by bees in Europe alone is estimated at around $250 billion per year, In the United States, $15 to $20 billion annually. It's a service nature provides for free, as long as the bees are there. In Sichuan province in China, after decades of uncontrolled pesticide use wiped out local bee populations, farmers were hand-pollinating apple orchards with small brushes, flower by flower. That's not a hypothetical scenario. It happened, and it's still happening. Back to that emptiness in Hackenberg's hives in 2008, scientists have established that colony collapse disorder isn't caused by one thing. It's several factors working simultaneously and amplifying each other. Pesticides, particularly neonicotinoids, a class of insecticides widely used in agriculture. They don't kill bees outright. At low doses, they disrupt the nervous system, impairing navigation and memory. A bee that's absorbed a sublethal dose simply can't find her way home. She flies out and doesn't come back. That's exactly what Hackenberg saw. Not corpses, but the missing. The European Union banned the 3 most dangerous neonicotinoids for outdoor use in 2018. In most of the world, they're still in use. The varroa mite, a parasite that arrived from Asia. It feeds on the bodies of adult bees and their larvae, suppresses their immune systems, and spreads viruses. Today, varroa is present in virtually every hive on the planet, except in Australia and a few isolated territories. Without regular treatment, the mite destroys a colony within 2 to 3 years. Habitat loss. Industrial monoculture farming, endless fields of wheat or corn, is a desert for bees. No diversity of flowering plants, no food. Urbanization eliminates meadows and wildflower roadsides. Climate change. Flowering seasons are shifting. Bees tied to a specific seasonal cycle arrive too early or too late when there's no nectar yet or the bloom has already passed. Pathogens, fungal infections, viruses, bacteria. Bees already weakened by pesticides and varroa fight off disease much less effectively. Any one of these factors alone is manageable. Together, they form a systemic crisis. Year 1, fruit, berry, and nut harvests collapse. Prices spike. Farmers attempt hand pollination and drone-assisted pollination, hundreds of times more expensive and slower. Years 2 and 3, food shortages become tangible. Many species of wild flowering plants vanish. With them go the insects and birds that depend on them. Ecosystem collapse begins cascading upward. Years 4 and 5, the global food production system faces collapse. A third of what you're used to eating is unavailable or has become a luxury item. This isn't science fiction, it's the assessment of the UN Food and Agriculture Organization and the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. Robotic pollinators are already in development, tiny drones with bristles designed to mimic what bees do. Self-pollinating crop varieties are already being engineered. Artificial pollination via pollen misting is already being researched. But replacing 2 billion years of evolution that built the perfect system, that can't be done in a few years, maybe never. Bees have existed for 100 million years. When dinosaurs still walked the earth, bees were already moving from flower to flower. As civilizations rose and fell, bees were building their own. The same system without fundamental change for 100 million years. We've managed to create a deadly threat to them in roughly 70 years of mass pesticide use. There are things you can do right now, not at the scale of government, but at the scale of 1 yard or 1 windowsill. Plant flowers, lavender, marigolds, clover. Don't mow your dandelions in early spring. They're the first food source for bees coming out of winter. Skip the pesticides in your garden. If you spot a swarm of bees, don't call an exterminator, call a local beekeeper. They'll collect them for free. This isn't sentimentality, it's pragmatism. A creature weighing 120 milligrams with a brain weighing 1 milligram has been doing its job without interruption for 100 million years. Maybe it's time we finally started paying attention.